So my name is Jim Wooley. I am a senior principal at Slalom. We are an international consulting firm. We do consulting both on technology and business and data and pretty much all the gamut of things so we can bring a full team together and be able to solve problems for you. So today we're going to be taking a look at C# source generators, and these actually aren't something that is brand new. This has been around for some time now. Source generators. Source generators are part of a broader category of metaprogramming, which is basically writing codes to interrogate code to write code. Is basically the kind of things you're looking at here. And we've been able to do this, and all sorts of platforms have versions of meta programming, be that source generation, be that through reflection, which is probably the key way. If you've written anything meta programming based, it's probably done some reflection internally to do something and then automate some other thing. Macros, more so in the C++ world, and aspect-oriented programming is really big in the Java world, for example. We don't do as much aspect-oriented programming other than things like adding attributes to our C# classes, which tell us that we're going to do something else. Like data annotations would be attributes in that regard. Or Entity Framework has attributes to be able to say how the database is going to be created. And then things can interrogate that information and generate new stuff based off of those. Scripting has been around at least since C# 4, and that was to be able to support scripting and interrupt with JavaScript libraries and Python libraries, which sort of got abandoned as soon as they released it, I guess. But the capability is still there. And interestingly, they're sort of coming back with the file-based apps that they just introduced with .NET 10 last week. And so the scripting is an ability to do some of those kinds of things. And then reflection, as I said, is pretty much a common way of doing those with C#. But there's one challenge with most of these aspects, and that is that these are all dependent on runtime evaluation. And runtime evaluation, for example, particularly with reflection, can be slow. There's a performance penalty that happens with the runtime reflections. And this doesn't allow you to then interrogate what was actually generated to be able to make tweaks on it, or say, well, now I need to correct what I'm doing in order to do something differently. So what can we do if we actually want to do these, not at compile time, or either at compile time or even better, while the developer is actually making changes directly? And that's where C# source generators come into play. As I said, these are not new. They've been around since C# 9 and .NET 5. So they've been around for some time. They have evolved a little bit over time, but the basic concepts still apply. These are ones that are going to be running during the development time. As the developers are making changes to their code and they're saving changes to those files, then the source generator is going to intercept that and say, oh, do I care about that particular change for that file? And if so, make whatever changes that they actually have annotated for that one. They're going to increase your runtime performance because we've already pre-evaluated that and we don't need to evaluate it again later on. And we can also potentially be able to have that implementation a lot more performance optimized than what a reflection-based approach would potentially be. And so we can generate new source files that are going to be added to your project, and they may be able to be checked in, or you may not need to check it in as part of the build process. It's just going to go ahead and build it all dynamically itself, and your developers are going to be able to have the experience otherwise. One of the great things is we eliminate reflection, and by eliminating reflection, we can then sort of enable this ahead-of-time compilation, which is becoming more and more of a thing with the .NET world. Anybody heard of AOT at this point? Okay, some of you. With AOT, that's one of the initiatives that they've been doing, particularly in the ASP.NET world, and also those who are going to be doing Azure Functions or Lambdas or things that need to be really smaller and be able to spin up faster, right? And get the performance as fast as it can. So what is AOT? We increase the performance, we decrease the startup time, and make a smaller deployment size by taking the application and the compiler checking through all of the paths that the code can go through. And if it finds a path or a branch that it can't actually do, it's going to tree shake that and eliminate that piece of the code base if it actually isn't consumed anywhere, which reduces the size of the application. Well, what's the problem with that? Well, if you're using reflection, anything that reflection-based, the compiler can't check because it's runtime evaluated rather than compile time generated. And so at that point, it's just going to throw out anything that's reflection-based. which means anything like Entity Framework or ASP.NET bindings or things like that before they've started adding these source generators, they just get tree shaken away, and then it won't actually be part of your application. Your application won't work, right? So you're going to see more and more of source generators come into play in order to enable this ahead of time compilation process. And with the ahead of time compilation process, not only does it tree shake it, but it'll compile it directly to that platform. So you don't have the JIT in the first time compilation process that happens when you actually run your application. So that should increase your startup time tremendously. And they found a lot of performance benefits around it. Okay, so I said I'm not talking about Copilot. I kind of lied. We do have to compare it a little bit with Gen AI and sort of see where do these sort of pieces align. Because there is a little bit of a parallel between what we would do with Gen AI and what you're going to do with source generators. One of the great things about source generators is that they are deterministic, which means that I can make sure that the code that gets generated is going to be the same code every single time. And it's going to be optimized specifically to what my needs are and how I'm going to make sure it's done. With Gen AI, it's non-deterministic. It's not going to generate the same thing every time. And each time, if you try to generate it, it's going to be absolutely positive that I know exactly what you want, and it's going to do the exact thing that you want to do. Unless you ask it, are you sure that that's what you want to do? And it says, well, no, not really. This is absolutely what you should do instead. Right? Anybody see that one before? Yeah. Yeah, so making sure that it's deterministic, making sure that it has the best performance, best use of allocations, and doesn't have extra allocations that aren't necessary from a memory perspective and such are really good. The triggers with Gen AI is based off a prompt. So you want to do something, you have to tell it, do this again, right? Well, if I make a change to a class and I want to have a mapping property which is going to map to my data transfer objects, I'd have to tell it, now I've changed this class, now map to a new data transfer object and create the new data transfer object. Why do I have to do that every single time? And that's sort of adds additional overhead. If we use a source generator, if I tell the source generator, hey, this file needs to get mapped over to this data transfer object, then the source generator says, okay, so when you add a property to that original class, your model class, it's going to automatically add that to your data transfer object and automatically create the mapping for that data transfer object for you. And you don't have to make the changes yourself manually. The real purpose on the source generators is to automate your boilerplate code, automate the mundane types of things that typically happen as compared to learning, being able to generate some new stuff. Generator of AI is all about let's generate something new as compared to let's keep updating and maintaining something that I've already created, right? What are some examples of source generators? Like I said, they started coming out back in the .NET 5, .NET 6 days. And when the first version, when .NET 6 came out, they went ahead and started adding to the framework directly some things which were going to optimize performance. And one of the performance optimizations they had was around logging, to be able to eliminate some of the runtime late binding aspects of logging and be able to optimize that to a more compile time version. And so here I can have a strongly typed method, which is for logging, and I put annotations on the method, and then it's going to be able to then figure out, based off of those annotations, that I'm going to source generate the rest of that and be able to optimize that. We're going to see that when we actually jump into Visual Studio in the code there. Now with .NET 7, they added one for regular expressions. And on the regular expressions, instead of having to evaluate that regular expression when you try to call it the first time, then it's going to evaluate that while the developer is actually writing the code and make all the evaluations and tweaks and such. And you can see that the performance, using benchmark.net, that the performance on the compiled version even is slower than the version of the source-generated version. And it would be a lot slower if it wasn't a compiled regex, but was actually just a standard regex that wasn't precompiled, because with a compiled one, it's going to evaluate it one time and then use that one-time version over and over, rather than with the source-generated version. And the people who wrote the source-generated version of that are the same people who do the real heavy performance monitoring around .NET. I don't know if anybody's seen Stephen Tobe's sort of missives, the 200-page long blog posts around performance on every version of that. He contributed into parts of those as well, right? With .NET 8, .NET 8 says, well, we're doing a lot with JSON, so how about if we can optimize the serialization for JSON too? And so here I can just add an attribute, say I can then serialize a person object, and by saying that, then it's going to be able to generate the code to be able to serialize the person object. And the great thing about this is we'll be able to see exactly what it is that it generated when we get into our code. .NET 10, which just came out last week, released. They added in with Blazor form validation. And on the form validation, it brings back the old data annotations that have been around since, C# or from .NET 3, 3.5, somewhere in there. And with this, then these are actually now going to be source generated as well, rather than the reflection-based approach. So beyond what's in .NET, there are a lot of third-party generators as well. The GitHub repo I put up at the top there has a list of a lot of the source generators that are out there. They cover all of these various categories. And if I jump over and show you the page, you can see that the list of these is pretty extensive. So I'd say you probably want to take a look at if you're thinking of one of these might be beneficial. And no, I'm not going to pause for you to read all of these in depth at this point. If you find one of these might be beneficial, then take a look at that. If you're finding that you want to create one, then these are great representatives because these are all open source libraries as well. So you can then see how did somebody else do this thing, and then maybe piggyback and extend that to be able to do what it is that you want to be doing as well. Right? Let's get into some code. So here I'm going to jump into Visual Studio, and in Visual Studio, I want to then Solution Explorer. Let's start out with the logger one, which I mentioned was one of the first ones that .NET came out with itself. And so with the logger one, again, I can just put a method on this log class, and on the method, I can put attributes on or annotations on it. And with those attributes, then I can then take that and extend that. So we'll notice when I'm defining this that this is a partial class and a partial method. Because with source generators, we cannot change your code. We can add new code, but we cannot change your code. But if you want to stub in what you're going to be doing, that we can then make a modification on, you can do it as a partial, and then the source generated version can do the actual implementation of that partial method. So let's take a look at what this looks like. On this could not open socket method, if I can come down here and see what are the methods in this class, we actually have two versions of that same method. One is the one that I wrote, and the other one is the one that the source generator wrote. And we'll see here when I go into the source generated version, it actually at the top says, this file was generated by that particular source generator and cannot be edited. And in fact, if I try to come in here and make a change to it, no, I cannot edit it, right? But I can rerun it, and it's going to run dynamically as well always. If I wanted to take a look and see what all of the source generators are in here, I can actually open up the analyzer's view of the dependencies and find the logging generators. And in here, if I expand that out, I'll actually see the same way that we can do with analyzers and see what the analyzers are that an individual library can consume. We can also come in here and see what are the generated files that one can consume as well. But here we can see the actual implementation, and we're going to take that class or the partial method and do the implementation on that one. The implementation on this one's pretty simple. It's just going to define a logger message, and with that logger message, it'll actually set in the level that we're going to do it at, and all of this. And so none of this is reflection-based. It's all going to be real-time compiled versions and where. So this isn't that difficult code to actually write. But it's a little cumbersome to do it over and over and over again. So let the generator handle the heart of the matter, and you can deal with the easier stuff first and work with the business applications themselves, right? So that's one. The next one is a little more interesting, and that's going to be the regex. So with the regex, here's how you would typically do a regex today, and you can create a new regex, do a check on match, and see if they're going to be equal. Okay, that's not too bad. Now with the new one, we can then put an attribute on which has the regex in it itself. So this is going to be generated regex, and this is going to be a partial partial method, which is going to get the email regex instance object. And so if I then F12 on this one, we see, oh, there's another source generated file. And in this source generated file, no, I'm not going to look at all of this in depth because this is what you have to write, or what the compiler has to evaluate for a regular expression. Do you want to write this code? I don't think so. But if you look and really examine what's going on in here, you'll see that there are a lot of performance tweaks. They're using span of t. They're popping on the stack and pulling off of the stack and doing some low-level memory kinds of things. There may be even some unsafe pointer operations inside of here. And so really trying to hyper-optimize the performance, which are things that you're probably not going to do yourselves. But all your code then just needs to be is, well, we just have a regex. And that's a lot more simple to maintain, right? And the performance in this is going to be significantly higher as well. Now, we've probably not only done that, but we've probably done JSON. And so here with the JSON one, very similar with the other ones, where we have the old way of doing it, which is JSON serializer, serialize it. Okay, fine. But for the new one, we can then say that we have a partial class that is going to be a JSON serializer context, and it's going to then say, through an annotation, that we're going to serialize a person for this one. And so that's going to set up the generated version of that so that when I come down here and try to serialize, it's going to already know that here's how I actually serialize that JSON structure. And if I scroll down here, you can see some code that's going to look pretty familiar to how you might do it if you're trying to do it manually. Here I'm going to do the serialization handler, and inside of that we're going to write the start object, and then write the string of the first name, the last name, and then if we have children, which is an array of other people, then we're going to iterate over those children as well. It's a pretty simple, straightforward stuff. Now, just to prove that this isn't just hand-coded otherwise, let me go ahead and pop this down below. Okay. Pop that down below. And let's see what would happen if I changed this person object and added a age property, for example. So public int age. Come on. Okay, nothing happens yet until I save this file. But when I save the file, if I look down here in the generator, the generator should have automatically regenerated at 820, which is right now. And if I then see I have a right number of age as part of that operation now, which wasn't there before. Right? So that way it's automatically keeping up with the changes that the developer's making in real time and updating that. I didn't have to go back out to Copilot and tell Copilot, okay, rerun that mapper for that JSON structure. It's going to do it automatically for me. So any questions so far on that, in terms of how you might be able to use some of these? If I wanted to use one of the third-party ones, I just go out to NuGet, install the NuGet dependency for that. It's going to appear as my analyzers, and then I'm going to add to my code what other annotations or triggers that you want to use. There are a number of ways that you can trigger these, but for example, if you could trigger it based off of, does this class have this interface dependency, and do it off of that. The way that you see almost all of the analyzers work at this point, though, is off of attributes, and triggering it based off of, does this thing have this attribute that I'm going to then be able to pick up and extend. In part because that's actually one of the fastest ways of identifying those and being able to extend those out, is through attributes. So let me just jump back over to some slides here so we can start talking a little bit about source generators if we wanted to not only consume them, but also to write one of these yourselves. And here's where we start getting more into the compiler theory parts of this. So a source generator, when they first came out with it, had some design principles. One of the key ones is, thou shalt not change existing code. You can only add new code, you can't change existing code. Which made things like being able to do I notify property changed with auto props a little bit of a challenge, because with auto properties, you can't extend an auto property. So how do I then add things to that auto property in code gen now that notify property changed event handler without being able to extend that? And so originally, there's a sample that you can get for the Roslyn source generator samples, which does identify property changed. And what they did was they put just the field on, and by having the field, then they magically created a property backer, which you would be able to consume, and you could put annotations on the field to say how you actually wanted that mapped. And that way the source generator would create the properties. Now, since that one originally came out, they've added things to the language, including partial properties. So now I can have a partial property and put an attribute on that partial property that says, and now do that as an unnotified property changed implementation and be able to extend it that way. And that's why also you've seen in the most recent versions of C# things like partial events, partial constructors, to be able to continue to extend those capabilities. And you're probably not going to be writing a lot of partials unless you're wanting to do things with generated code, whether that being through source generators or through T4 or any other of those generated kinds of implementations. You can also create diagnostics or analyzers to be able to say, for this particular source generator, then here is something in this domain, which is the way you should be consuming this or the way you should not be consuming this, to be able to extend the capability for that. Also recognize that these source generators have to run sort of atomically. They can't rely on or be serialized with other source generators. So for example, one of the challenges I think we're going to see with the data annotations and the validations right now is that I believe the source generator for a regular expression doesn't actually, from data annotations, does the string version of the regex match and doesn't do the new compiler version of that, because we can't generate the class which has the compiler version and then generate the compiled version from that, because we can't have the dependency of the source generators one on top of the other. So they have to be atomic, and they can't rely on a specific order from the other ones. So with those principles, then, well, how do we create one of these? Well, the first thing is we have to implement an interface. When it first came out with C# 9 and .NET 5, it was a really simple interface, which is an iSource generator. With the iSource generator, we have two methods, which is one to initialize it and set up what are the kinds of things we want to pay attention to. And then the second part of that was when we find something that actually meets the criteria, then we're going to do something on top of that and evaluate what the code was around that. But there was a problem with that version, and that is the performance. So those source generators were running every single time, for example, a class was modified, which is pretty frequently, yes? And it was running across all of the classes, not just the one that it cared about, because it had to figure out, of all the classes, is this one something that I care about or not? And so the performance in that really started to go down. And the source generators were causing the rest of your development process to get slower and slower and slower. And so with .NET 6 and C# 10, they added an incremental generator, which was optimized to say, well, let me take a cache of the kinds of things that I'm paying attention to and notice whether or not that thing has changed. If that thing hasn't changed, then I'm not going to evaluate it. I'm only going to evaluate those that have changed and be able to make the modifications on that. And at this point, if you try to use the old .NET 5 iSource generator, the compiler is actually going to tell you, nope, this is legacy only. You cannot actually create new ones of this. And so you're going to be blocked from doing that. You're going to have to use the incremental generator now. And this is all based off of Roslyn. What was Roslyn? Roslyn was the rewrite of the compiler for C# and Visual Basic. They spent about 5 years rewriting that back in the between 2008 and shipped in 2012. And with Roslyn, it not only was the rewrite of the compiler, but it also was able to open up the compiler. So before Roslyn, you had source string files, essentially, which then you had some black box that was a lexer and a parser that was able to evaluate the values inside of the string file and figure out what actually needs to get generated in order for the computer to understand that, which is the intermediate language. And then the intermediate language at runtime would be reevaluated again to go into bytecode to actually be executed by your processors. And so with Roslyn, not only did they rewrite the compiler and dog food the language itself, but they also opened up the black box to expose what was brought out from the Lexer parser, which is the abstract syntax trees. So that with those syntax trees, then you not only could they interpret it and interrogate it for their own tooling purposes, but they also supported the ability for others to be able to get into that and use the same mechanisms to understand what's going on in their code. And one of the great things about this is they have to keep this up to date with newer versions of C#. Each time a new version comes out, then they need to be able to understand what's going on in that. And that means that you're automatically going to be able to take advantage of that new capability as well. So if there's a new language feature, you automatically know what that new language feature is, for example, here. Has anybody actually had to do a creation of a Lexer and a parser and create their own compiler for something for school? Okay, one back there. It's not an easy process, is it? So this way you can just take advantage of everything that they've already built for you. So let's see, okay, so just how easy is this? Here's a pretty simple method, right? What does it take to generate that method? Well, there's quite a bit. And actually, I'm going to jump out of slides here and go back to code so we can really see this at play here. So if we have my class, let me go ahead and create I get a method. Let's see here. Yeah, I'm not going to do it in there. Yeah, actually, let me pull up one of my tests. Okay. So let's just do var x equals 1 plus 2, right? So with that, I have a very simple method. What does this actually look like to the compiler? So if you could add the compiler SDK tooling, one of the things it's going to add is the syntax visualizer display. It's under Tools, other windows. And with that, so then I can actually interrogate and see the syntax tree for an individual node. So here I can click around on my application, and it's going to show me where in the syntax all of these pieces are. So at this point, I have on the X, and I can click inside of here to see, okay, so what does that actually consist of? And I can come down here and I see, well, that whole line is a local declaration statement. And that local declaration statement has a variable declaration with an identifier name, and that identifier name has an identifier token, and the token itself is the string of X, right? And then it's a variable declarator, and that variable declarator has an equal value clause with an add expression with two numeric literal expressions. And not only do these have numeric literal expressions, they also have what's called tokens, and also with the tokens, there's also trivia. So if you'd written your own compiler, you didn't care about the trivia, probably. You eliminated semicolons, you eliminated spaces. Those are all things to be able to find out what are the individual pieces that we're actually dealing with. But with Roslyn, they needed to be able to create analyzers and refactor tools. And the refactor tools wanted to make sure that if you have a comment, I'm going to keep that comment. And so a comment is a kind of trivia. Sometimes developers are really particular around the spacing of things, whether they use tabs versus spaces, but also if they want to make certain indentations to make things line up, like the type versus the variable name versus the declaration, for example. And so they need to maintain those pieces when you refactor your code. Now, if you don't understand how all of that works and think a little bit more visually, you can actually, if you have the DGML tool built in, they actually allow you to be able to see the directed graph syntax, to be able to see a tree version of your source code there as well, to be able to identify where things are in this particular source. Now, for what we're doing with source generators, we don't necessarily need to generate this code in this particular way, but we do need to be able to interrogate the code to be able to find things that we care about, right? And so what are something that we might want to care about? Well, we might want to care about something that has an attribute on it, right? To be able to find out what's an attribute that I actually I'm looking for. So here, As we're going through, then we can find that we have a syntax token. And on that syntax token, it's a method declaration. And that method declaration then has properties. And this is the metadata around this particular class that has an attribute list. And that attribute list then can list the various attributes that we can actually try to find something about. So if you've ever done anything with reflection, this should look a little familiar, right? But one of the nice things about this tool is it allows you to see this a little more visually rather than just trying to dot in through code and be able to find those things out, right? So let's say I actually wanted to create one of these puppies. Well, let's go ahead and start doing that. So the example I'm going to do here is to take an object. In this class, it's going to have a first name and a last name. And then I'm going to say, I want to be able to serialize this via CSV. So I can then create the names of the individual things. I currently am not setting up to say and change the name of this to use an alias of another name, and I can add an attribute on the first name to be able to interrogate that, or say this is the ordering that I want these to appear in, or exclude this one. So there's a lot of extensions to this that I sort of leave to you as my co-developers in an open source world to try to extend the sample that I have here as well. And also I'll say that if you go to and download my source, if you find any bugs in there, I left them there intentionally so that you can learn. You're welcome. Okay, so here I can just say, well, I'm going to do this as a incremental serializable attribute, and we'll see where this attribute actually comes from. And then I'm going to be able to consume that. So here I can have a new person, and the person class doesn't have this .toCSV method on it at all, does it? But we can do that, and if I do dot on this, we'll be able to see that we should be able to see. What? Okay. Yeah, interesting. So if I do it there, it would actually work. So here I see we get the first name and the last name, and we have this toCSV method. And if I then look at this, I can actually drill into this, and here is the toCSV method. It's on a partial class, and notice this is inside of a generated file, right? So what we need to be able to do is to be able to generate this class, generate the file, and this file looks pretty simple and straightforward. The first thing is we're going to be able to set the first name and the last name inside of a string, and we're going to put quotes around the string values. So that now I'm not escaping if that string had a quote in it itself. I'm not escaping that quote, and you probably could extend this a little bit more and make it a little more safe in that regard. And then I'm also going to create a method to be able to find what were the property names and then create the header line for that CSV. And then for good measure, let's say we were sent an array of these or a list of these or whatever an enumerable is of those kinds of things. I could then iterate over those and call into the CSV on each one of those items and also get the header and create a whole CSV file which includes all of the items that are in that list, right? Could be useful. Not too hard to put together. So if I were wanting to implement that, what would we need to do? Well, the first thing is I need to figure out what's a trigger method that we're actually going to trigger these off of. And if you saw, I have an attribute to be able to trigger that. And that's probably the easiest way to do that. Where did that attribute come from? It's not something I've generated in my class itself. It's actually part of the generator itself. So in the generators, we have the ability to create code. And this code can just be standard strings. Because essentially, when we're writing code, we're just writing strings. We could write our code in Notepad. In fact, the very first versions of C# that came out back in 2000, they didn't even have Visual Studio with it. And you had to do CSC and CLI tooling to be able to compile your applications. So we just have strings, and this string is going to declare an attribute. In this attribute, we're going to call CSV serializable attribute. And then how do we actually consume that? Well, on the execute method, we're going to add to our source a file which is going to be a generated file. And the generated file is going to contain the text of what we generated up here. And there's no real generation. This is just a static value here. But recognize that this is getting generated on execute. So every time that we're executing my generator, it's going to rewrite that, which might not be ideal. Right? This is the old C#6 way of doing this. And you'll notice, or the .NET first version, you'll notice here I actually have that iSource generator commented out. Because if I do put it in there, this is going to say, this is the original CSV generator that works with .NET 5. iSource generator interface has been deprecated and replaced with the incremental generator interface with .NET 6 and later. It's still included for reference purposes in older projects, but you should not use that for newer projects. I'm going to keep looking at this a little bit because the code is a little simpler in this version than it is with the incremental version. And then I'm going to go to the incremental version to sort of show you the difference between the two of those. Okay, so here we have both the execute and initialize. So let's start with initialize. Initialize is going to then say, well, so what are the kinds of things that I care about? And I actually have a separate class that says, here's what I care about. And you'll find very often when we're dealing with these source generators, we're going to use a visitor pattern to be able to iterate through graphs of the code itself in that syntax tree. And so here we're going to be able to find, for the syntax node, to find anything that is a class declaration syntax, because we want to find classes that have this annotation on them. We could have this as a method declarator syntax if we're wanting to make annotations on methods, right? And properties and such. And so it's a matter of trying to find out what is the data type that we actually want to consider here. And the number of data types that are out there is large. I am not going to be able to teach you everything there is to know about Roslyn in this hour. That's just what are the class syntax types that the compiler knows about and cares about. We can do the same thing with what are the various syntaxes that we deal with. But here we're going to say, okay, so I want to make sure that we have a class declaration syntax. And if it's not a class declaration syntax, escape out of this, ignore it, don't do anything else. Because we want to make sure that these run as fast as they possibly can. Because recognize, these are happening when the developer's typing. And we want to make sure not to get in the developer's way on these. So we want to make sure that these are going to be able to run really fast. So we have the syntax node, and we get a class declaration syntax. And then we're going to say, okay, so does this class declaration have any attributes? If it doesn't, get out of the way. If it does, is the attribute that we care about? If not, ignore it. Otherwise, let's keep working on this one. And this is, again, going to evaluate every single time we save to see, okay, did I make any changes or not? Even if I didn't make a change to that file, it's going to reevaluate and do that with the old version of the source generators. But what is it going to do? It's actually going to do what's in the execute method. So let me not save that and come back here. And so the execute, this is where we actually do the heavy lifting of, at this point, adding the attribute itself, and then say, if we're not a CSV generator syntax, so one that we recognize, then skip out of that. Otherwise, let's do the work. So here we're going to get the syntax trees off of the parser, and then we're going to parse the text from that syntax tree. We're going to then get the information from that. And this is all sort of how do we get the metadata around that particular class. And once we have the metadata for that, then we can start building up the new class that we're going to generate. So at this point, if you've ever done string manipulation, you should be able to figure this one out. We're going to do a string builder. We're going to append in namespaces, using clauses, the static class, and then for each of the class declarations that we received that match the attribute that we care about, then we're going to continue on. And here I'm going to say, if the class, although it may have an attribute on it, it may not be fully saved yet. So this has to also work with partial and broken code. It doesn't have to compile in order for these things to work. So we need to be able to make sure we're handling that appropriately and escaping out as necessary. We're going to get the semantic model. So we're not just dealing with strings and strings, we're also dealing with the semantic model of what is the class and what properties does that class have and what are all of the dependencies. So for example, if you've ever done a search and just do a string search, you have multiple classes that have the same property name, then a string search is going to return all of those, whereas a semantic search is only going to find those that meet that or go to that exact same class property name, right? So it's a little bit broader on the semantic models, which means it's an additional overhead on getting the semantic model as well. Then we can, from the semantic model, we can get the symbol and interrogate that a little bit more to say, does this symbol have a namespace? Does the symbol have an identifier token? And making sure that we're adding the namespace if we need to add the namespace, or is it in the global namespace, for example? And based off of all of that, then I can say, well, here is the class name, and I'm going to put that inside of a region on this particular implementation. And then I'm going to say we have a static string to CSV for this class name with the namespace. And then we can get the properties from that and generate out the comma-separated values of those properties, basically as strings, and evaluate those. And you notice there's no reflection in here. We're actually doing, setting the property, and then the property accessor is not going to need to be reflected anymore. It's going to actually just have a regular dot into that property in the class that was generated. Do the same thing for the CSV header and for the enumerable implementation as well. Okay? So once we have all of that generated, then we just add to the context, which is the compilation unit. We're going to add this source, which is here the CSV generator.g. It doesn't have to be .g, it's just sort of a convention-based approach, which we've had for a long time to say this is a generated file and keep that out of the way of everything else. And we're going to then add the source that we just generated from that string. Okay? So there's a lot of code in here. If you've done reflection, you're probably going to be able to figure out what's going on. The first time you try to write one of these, it's not going to be easy. And trying to understand what are all of those pieces inside of that tree is really the most complex part of this whole process. In all honesty, most of you in here probably are not going to do this. You're probably going to go out to the list that I had before and find something that already does one of these and just consume that. But I want to make sure that you know, if you want to go out and do that, or you need to extend one of those, this is how you're going to be able to get in to be able to do that. Right? So that was the old way of doing a source generator. In the newer way, with C# with .NET 6, and then there was another extension, .NET 7, we have the incremental generators. And incremental generators have some of the same behaviors. And in fact, the chunk of code which actually does the hard lifting of actually generating the file is pretty much the same as the other piece. The real distinction with the incremental generator is how do we do the initial wire up so that we're not automatically going to be rerunning this every single time somebody makes a change to any code. We want to make sure this runs only when somebody is making a change to code that we care about, and only to that one or two classes that we actually care about. And that's what the incremental piece of this is. So with an incremental generator, that only has a single method, which is initialize. And on the initialize, that we're going to set up and say, instead of on the execute, generate that attribute file, we're going to do that one time and one time only on the initialize. Now there's actually a downside to being generating inside of this. So if I have this generator associated with one project, and it's generating this attribute as a public in this namespace, and then I put the generator also to another project in my same solution. Now I have two projects in the same solution that have dependencies on this newly added attribute, and then we can get naming collisions between the two of those. So if you start to run into this problem, there's a blog series by Andrew Locke that I'll have a link to later on, which explains here are some valid options that you can do to be able to fix this problem. So we won't go into the depths of that one, but there is a potential downside to doing it this particular way. But here I have the incremental source, and that piece of it just looks pretty much the same. Here's the string value of that incremental source generator. I do have it as a different name so that I can have in my project both the old version and the new version running. But typically you wouldn't have those separate there. But yeah, we'll go ahead and add that for this one here. And then if we're in .NET 6, we would create the syntax providers, and on that we're going to say, okay, so is this a syntax that's a target for this generation, and evaluates that attribute a little more dynamically. With C#7, or with .NET 7, they recognize that almost all these generators are using attributes, so let's give you a helper method over those attributes so that you don't have to create all the cruft of going through and parsing and going through the attributes. So we're just going to say, for attribute with metadata name, and then pass it the name of that attribute. And that way we can interrogate that and let the platform figure out where do we want to care about that. We can add additional qualifying clauses on that one to exclude certain things if we wanted to. In this particular case, I'm just going to return that it always is going to run for those. And then we're going to transform the output of that we found into a type that will be able to be equatable to see whether or not we made a change to that. So this is one of the key things with the incremental generators is we want to performance optimize to see, let's care about only things that changed. Now, how do I do that? I'm going to get the information for the class that I care about. Now, we don't want to actually just pass that class declaration syntax, because that class declaration syntax is going to be an object, and that's going to have object semantics to be able to do equality, to say, is the pointer to this object the same as the pointer to this object or not? But that doesn't necessarily mean that those have the things inside of that changed or not. So we want to do value semantics rather than reference semantics to be able to see, okay, are the things inside of there, have those changed or not? So I'm going to then extract that in my own custom type. In this particular case, I'm going to use a record. If you're not familiar with C# records, records are classes, essentially, that you cannot mutate. So that makes performance optimizations better, and you can parallelize those operations better. And it uses value semantics rather than reference semantics to say, it automatically does the IEquatable to say, if the values in this thing equate to the values in that thing, then consider those to be equal. And so if they both are equal, then this hasn't changed, and I don't need to worry about it. If it has changed, and we can also customize it to say, and have these particular pieces of this changed. So for example, in my CSV implementation, I only care about the properties. I don't care if they changed a backing field name. I don't care if they added an event to it. I don't care if they added other methods to it. I only care about the properties because that's the only things that I'm going to expose for my CSV implementation. So I have the ability to figure out exactly what it is that I want to get. And so how do I do that? I'm passing the type to this constructor, and this constructor then can say, well, let me figure out what's the namespace, what's the class name, what are the properties, and if the property has an array of other properties, then what are those properties? And for those arrays, then I need to make sure that the array of properties is also equatable, and making so that we're going to be optimizing that as well. This is probably the biggest heavy lift difference between the .NET 6 version and the .NET 5 version and the .NET 7 version is being able to performance optimize these particular pieces of that. So with that, the rest of this is going to be pretty much the same. So I have inside of here, I'm thinking incremental generator, this one. So we then register that we're going to get those classes, and so this incremental generator is then going to say, if we actually find something which we care about, now register that we're going to do work and execute to actually do the transform and evaluate what it is that came out and run that. So that execute method is right here. Here's where we start creating our string builder. We get the string values. And since we've already evaluated the things from the class, I don't need to go back out and get the metadata of the class anymore. I already have all of those things pre-cached in memory, so I can just dot right into this. So the class info, I have a namespace. Okay, well, here's the namespace. And if I don't have a namespace, then I don't need to include the namespace in this particular file. So then we're going to create the class or record and say, well, is this a record? I already knew that from when I created that from before. So we can just consume what I've actually already pre-cached and get to the name of that one. And then create the actual class, fully qualified class name there. And then create the toCSV method with a string builder, go through the properties, and do some string concatenation with the string builders to be able to build out the property names for the CSV, for the header, and then just write out the rest of the strings for the rest of the class. And then the last step to do is to add that as an incremental generator, right? So now that I have this in here, I can just go back to my program. And let's say I wanted to take person and extend this one out to also get to the name. So I can get to my person class. And if I wanted to change this, public and age. And what's something else? Okay, birthday. Or I'm not sure why it's trying to tell me the birthday is going to be an int. How about a date? Right. Date, time. Okay. What's another property, just so that you can't think that I'm fooling? Give me another property that a person might have. Phone number. Okay, good. If I can type. Okay, so I get phone number here, and then we can consume this in my program. So I can say we got a phone number equals age is 42, of course, because that's the answer. Birth date equals today. Okay, and so now if I run this, remember I didn't change anything in my code here around the CSV itself, but if I then Control F5, it's running a little slow this morning. Here we go. And so now we see we have John Doe with 42, the date, and a string escaped of the phone number, right? And if I'm not sure exactly what's going on, I can also come back into the .toCSV implementation, and I can see the generated code from that, and we can see here basically just hard-coded in all of the property setters of using string interpolation to be able to get all of those pieces. And I didn't have to go in and make a modification. I didn't have to go in and say, regenerate this for me. I just recompiled, and magically it all has that happening as well. Okay? Make sense? Look good? Questions? Yes. Can this be easily debugged? It depends. On this one, it should be able to be debugged because I should be able to step through the implementation. In many source generators, they're going to have compiler step over to say that we're not going to step into the generated stuff. Because typically, you don't want to be, you want to be caring about, or the design philosophy is, you want to care about code that you're responsible for, not something that somebody else generated on your behalf, right? Okay. Yeah, as a maintainer of the generator, how do I actually debug the generator itself? Right? That's a whole different question, because recognize that what I'm writing here is code that if I were to try to F5 into the generator code itself, well, the code and put a breakpoint inside of the code, then I'm going to tell Visual Studio to run and do something to evaluate and hit a breakpoint inside of that. But the breakpoint is happening from from Visual Studio itself, and so at that point you have Visual Studio in a broken state so that you can't actually interrogate anything. Right? So one of the ways to do this is they set up a it used to be sort of an experimental version of Visual Studio, that you have Visual Studio attaching itself to Visual Studio in a secondary debugger, right? Talk about meta. And that secondary one has the instance to this particular extension where the first one doesn't, and then you debug into the other one. It's really slow, because then your debugger has to be able to hook into everything the Visual Studio has, including WPF, right? And WPF is a massive beast, and having to pull all the dependencies from Visual Studio in. So the recommendation approach is don't F5 to debug this. What you do, however, is use unit tests. And with Roslyn, it's best to use XUnit rather than MS-test. There were some hooks originally that were a bit of a challenge. So let's take a look at tests that I have for this generator. I appreciate that you brought that question up, because that was sort of the next thing to take a look at here, right? You knew where I was going. So if we take a look at that CSV incremental generator test, here we have a set of tests. And these tests are really pretty simple and straightforward. Essentially, we say, well, here is input source. And from that input source, we can then test the generated output. And in this particular case, I'm leveraging a tool called Verify. And with Verify, it's really great for being able to test larger sets of chunks of things that are going to be created, classes or whatever. And basically what Verify does is it saves out, here is the output file for that thing. And the very first time you run it, it's going to say, well, you didn't expect anything, but I actually generated this. Tell me whether this is right or not. And then if I want to say, well, I want to change it to generate this other thing, then in your test output cached snapshot, which is right here, I can then say, okay, so this particular method is CSV generator without namespace async. So I can find the generator without namespace async verified. And so this is what it's expecting to have been generated. If I want to say this is my desired state, but that desired state is different, I can modify what the desired state is in here, and then rerun the test, and the test should fail until I'm able to get the generator to produce that particular output, right? But with this, I can also come into here and say, on my CSV incremental generator, let's maybe, back when I did the first step of getting the class info, this is probably the sort of the meat piece of what we're doing here. So I can put a breakpoint inside of here. And then on my test, I can go back to the test. And here. And say, well, let's debug this test. And it should, once it gets the build completed and start up on the test itself, we should be able to step directly into the code that is inside the generator and be able to run various scenarios. So I can create a scenario which has bad code and make sure that it handles the bad code appropriately. I can generate for things that have a record. I can generate for things that have a sub-collection. And do I actually care about those or not? Okay, so now I'm stepping directly into my test itself. And because I'm doing that, then I can step into just F10 or F11 and step directly into this, which gets the information about all of the type information. And off the type, I can then also figure out what are all of the containing pieces. And again, this is all the stuff that Roslyn has brought up in the syntax tree to be able to interrogate on and be able to find information about. So as you're starting to learn these, you're probably going to want to be able to do this to be able to understand all of the things that it actually supports, or throw it into the watch window, and all of the kinds of things which we would typically do from a development perspective, you have the ability to do inside of here, and all of that through unit testing.
In the source generator, can you emit diagnostics or logs?
In the source generator, can you emit logs? You shouldn't in the generator have external dependencies, right? during during the development process, and make sure that you remove it before you deploy. I don't know if you have access. You might have access like to console and to write to console. I don't. You probably should not take a dependency on a logging framework, for example.
That's what I'm taking, just console.
Yeah, just console writing. Printf debugging kind of thing, right? I would go with this version of that rather than the other version. If you're running this at runtime, you're probably not going to get the console output inside of Visual Studio in runtime, right? So use unit tests to debug these, and unit tests are significantly faster than any other option, right? The other thing that you're going to run into probably as you start to do this is, okay, so I make a change and I want to test that. Well, in order to test that inside of Visual Studio, then sometimes you have to compile the generator and then close Visual Studio and reopen Visual Studio for it to pick up the new version of the generator because it's cached the generator itself, right? Remember, these incremental generators, they run once on the startup of the application. They don't rerun when you just make a change to that library. So if you want to pick up that change dependency, the unit test is going to be a better way of doing that. Good question, and good try. Any other questions? No. Let's see what we can do to sort of bring this home and wrap this up here a little bit. So we covered the syntax trees. If you wanted to actually write out that one line of code, this would be the code that you'd have to write that one line of code if you weren't just using string versions. So the easier way of doing it is just to write it as a string as compared to writing out the actual compiler stuff. And you'll notice also here, each one of these are using factories. So with Roslyn, you cannot change something in code, you can only create new code. And so that way they used factories to be able to insert and make sure that you're not actually manipulating code and doing mutations around it. So with metaprogramming is really around reducing those repetitive tasks. Things like mapping from a data model to a data transfer object to a view model, for example. That's a great use case for something like this. Replacing anything that you're doing with reflection-based approaches. How many people use reflection in your applications for some purpose or another, right? So those are the first things that you're going to take a look at to see how can I replace the reflection with one of these kinds of implementations. Because of that, then we can start to enable that ahead of time compilation process, which is going to increase the performance of your application once you're able to actually consume those as AOT-based applications. And once again, I'm putting a link to that list of all of the source generators that are in open source. So if you wanted to try to find one either to extend or to just consume yourself, then go for that. So I did take a couple of performance comparisons around some of these various tools. How many people use AutoMapper? Okay. AutoMapper is not the most performant option that's out here, right? And so on this one, I think Mapster is a source-generated version of being able to do similar kinds of things that AutoMapper does. But you can see here the performance difference between AutoMapper at 649 nanoseconds as compared to Mapster at 229 nanoseconds, right? And I don't include in here, yes I do have the allocations and how much memory is consumed, and also from the allocations perspective, it gets into how much garbage collection is performed. And anytime you run into a garbage collection, then you're sort of pausing your process to do your garbage collection and then move on forward. So that's going to take a performance hit. And any way that you can reduce the number of allocations, the better your performance is going to be from your application perspective. And if you don't believe me, I got a link down at the bottom of here. And all the slides are available through the VS Live website. So you can get these and run these yourselves and just verify that it actually works there as well. Question?
I just wanted to mention, AutoMapper also just changed their licensing, so they're no longer a free version.
And with open source projects, sometimes their licensing evolves. I'll sort of reiterate your statement there. And AutoMapper, I guess, has been looking at some of those kinds of things from, how do they maintain it? And Jimmy does a lot of great work, but that doesn't necessarily come for free. And so you can contribute back into the projects, and don't just rely on them to provide your own support for them, right? So yeah, you definitely have to consider what are in open source, what are the costs, both from a monetary perspective and a non-monetary perspective, from a support perspective, right? So here's mapping. I was talking with Jason Bach yesterday, who's one of the speakers at the conference as well, and he's actually an author on one of these mocking tools called Rocks, which he works for uh, Rocket Mortgage. And so they came up with their own mocking framework, and this is an open source framework as well for rocks. And we'll see here, and if you use MOQ for mocking, which I actually do that a lot, some performance differences between MOQ and rocks is not only in the performance perspective itself, but also in terms of the allocations you see at the end. Now, it's not the fastest. The stub is the fastest because the stub doesn't do anything. The stub's not actually a mock, it's just a baseline. So, looking at those order of magnitude differences between these frameworks, you can see how that's pretty beneficial. Now, again, mocking frameworks, do I really care if it's that fast or that memory performant? Maybe, maybe not. Depends on how many unit tests you have, I guess. It's not necessarily going to increase or decrease the speed of your application runtime, but there are things to be considered when you're actually getting larger things. But it also shows that the benefit that you can achieve by using a source-generated version rather than a more reflection-based approach as well, right? So links for if you're interested in getting more in depth with source generators. I do have for the incremental generator. I'll comment that in many cases, if you start to research around this, you're probably going to find the earlier version of the iSource generator rather than the iIncremental generator in the references out there. So try to find ones that are around the incremental generator. That's going to be your more performant option in general. It is a little trickier to understand, but I will say that Andrew Locke, in his series of blog posts here, does a pretty good explanation of the trade-offs for doing those and how you can actually do those as well. He does have a really good example of how you use the verifier from a unit testing perspective also. Then there's the samples from the source generators, and there's the cookbook. And the cookbook is sort of these were the design principles and general guidelines of what you should and shouldn't do for source generators in and of themselves. And then they not only have the source generator from the first version, but there's also a cookbook for the incremental generators as well. Now, of course, the last link down at the bottom of there, that's the most important one, because that's where you can get access to the slides and to the samples and everything that I've actually created. I have a couple updates. I'll be putting those up on my GitHub. And also, this is GitHub, so if anybody does see an error in there, I'll take pull requests. Or how do you extend the CSV generator to be able to escape out quotes or handle nested types of structures? Or if you want to take that on as a challenge, one of the best ways of learning is by trying to extend something that somebody else did. Yeah.
Attribute that says this was source generated. Do you have to do that, or does that actually get applied for you?
So the question is, you didn't see anything in what was generated to say that to indicate that this was a generated file, right? Yeah. Yeah. And so with code, for people who couldn't hear, based off of that attribute, maybe a code coverage tool is going to remove those. Now, it's not something that I created. Now, if you need that for code coverage, maybe that's an addition that you need to add to the generator itself to make sure, because different code coverage tools may have different ways of exclusions, right? I haven't tried to see. Now, one thing to be aware of on this, though, as well, is it'll be interesting to see how code coverage actually covers that. I haven't thought of that before, is that these generated files, by default, are not included in your source repository. Okay? You can specify that they do get generated and sent to your source repository, but then you have merge conflicts galore all the time, right? And so by default, they are not included in your source. They are just generated at compile time or developer runtime, right? So the code coverage tools may handle those differently in that regard. By default. But yeah, there should be a way to be able to add that attribute, but there is no attribute which is automatically added. The compiler automatically knows about how that was a source generated version rather than came from an actual source in terms of the blocks there. Right. Good question. I haven't had that one before. If you want to go beyond source generators to other things that Roslyn can do, here's some links as well just for Roslyn itself and C#. So the repo for Roslyn is that first GitHub link. If you're interested in keeping up to date with what's going on from a C# language perspective, they have a page that keeps those up to date and says, as we're thinking about new features for the language, here's the status on where we are in thinking about it as compared to implementing it, as compared to shipping it. So it's a good resource to be able to stay in tune with if you're a language geek. And then for new proposals to the language, things that they're thinking about and evaluating, that's the proposals link. And then the broader .NET GitHub repository as well. And again, at the very bottom, that is my humble link to this particular presentation. So actually, the Roslyn Labs down there is a set of hands-on labs. And one of those hands-on labs is to create one of these generators as well. So I don't think I've updated it for incremental generators yet. But it'll at least get you started along the route of being able to do these. I hope you have a great rest of your conference here and great to meet you. Hope to see you at lunch and have a great day, everybody.